Welcome guys to my YouTube channel. Guys, we have a question here and we want to solve this question. Proof that the integral, you have 1 over pi, integral from negative pi to pi, x minus x squared multiplied by cos nx dx should give us negative 4 all over n squared multiplied by negative 1 raised to n, where n is a positive whole number. And so guys, we begin to do the question. The question, I have already done it, and thus we just observe guys as I explain. And so guys, we have the equation right here. We want to use what we call integration by parts. And so we say that this first part is u. Here we can give x minus x squared u, and then cos nx dx, we give it dv. After we do that, guys, we come and use the integration by parts formula, which is that. So what we are going to do, guys, we now differentiate first of all the u, so that we have the du, which is here. We have u, then du, all of is equals to 1 minus 2x dx. The dx was formerly here, I brought it here. Guys, we come and integrate this function. When you integrate that, you get sine nx all over n. So this is our v. Guys, now we come and input our figures in the equation. And so therefore, guys, this is our first equation. We are going to input our figures. So for u dv, guys, we don't need, this one is already right here above. So what we are now inputting, guys, is u and v, because already we have this, which has the u and dv. Now you come to uv. For uv, this is where now we come. We write 1 all over pi, which was formerly there. Then this is our u, and this is our v, according to the equation. Then minus, this now becomes our du, which is this, and for the v, it is sine nx n dx. Guys, for this u and dv is not for this first step. This one I am using it for the second step. And so therefore, guys, first step we are using the du, which is 1 minus 2x, and this v, according to this equation right here, v and du. So guys, after we have done that, replaced, then we already done with this figure. Guys, for this one we have completed. Now we are going to integrate this. Integrating this, our next step is where now we give 1 minus 2x, we give it u, and sine nx n, we give it dv. So guys, we now differentiate that. That is u is that, and then du, we write that. Sine nx all over n dx, we integrate that. That gives us cos nx n squared. So guys, from there, we just come and now expand from here, because remember that now we still use the same equation from here, so that now this is what now we get. This was from our first solution. Now we come to the second solution, where we shall have the u and v. The u is 1 minus 2x and v is cos nx n squared. And remember guys, that because of this negative, this one now becomes a plus. And now remember that this negative will still be there for this next. For this next term, we shall have this negative right here. And then we shall have these two negatives, guys, will cancel. So we shall have 2, then cos nx all over n squared, and here we have the dx from this, that is negative 2 dx. Can put the dx right here. So from there, guys, we just now integrate our last term. So integrating our last term, this is what we get. We shall write everything, and then we integrate this. This comes to negative 2 sine nx all over n raised to 3. Guys, for this term are going to be 0. And the reason is that if you come here, this we said is a whole number. So if you have sine pi, that because you have negative pi here and pi. Sine pi is 0, sine negative pi is also 0. So this term will eventually become 0. And also this term with the sine will eventually become 0. And so therefore, guys, we are just left with now this term. That is an. Guys, we are given our equation a value of an. So you may not ask where this an comes from, but we are given our equation a value of an. In other words, we are saying an, I think I have already shown you here, an is equals to that. So the an represents the equation. And so we continue. And so therefore, guys, we shall have an, and we now come and substitute for pi, and negative pi. So when we substitute, guys, as you can see, I have already substituted pi and pi. When it comes to positive, it remains like that. But now, guys, when it comes to negative, this one now becomes, for cos, positive pi and negative pi is the same. So that's what I have put. And so therefore, of course, for this is pi, and then we have the negative pi. The negative, this is negative pi, and this is now pi. And that's why this now sign changes, because here negative pi will change this one to positive. Guys, when we do that, we can factor out cos n pi all over n squared out, and we are left with this term. So when we do that, guys, now this will be 4 pi, and this one will cancel. And so therefore, finally, guys, we shall be left with, so from this, we shall say 1 minus 1 is 0. We are left with minus 4 pi. And here we have cos n pi n squared. Here we have 1 over pi. Guys, wherever we have this number, that is, this number will be from 1 and 2, 3, and then so on. So for the first case, we have pi. Pi will give us, that is cos pi will give us, that is cos 180, will be cos 180 gives us 180 cos gives us negative 1. Guys, when we come now, that is negative 1 first. When we now come to n equals to 2, that will be 360 cos will give us 1. And guys, if you go on, this one now becomes negative 1. This one becomes 1. There is that interchanging of sign. And because of that, guys, that's why now I come and put this. Because this one now becomes a GP. And the GP is represented by this term. That is negative 1 all over n. So instead of now putting cos n pi, we now put minus 1 raised to n, which represent a GP of that series. And so therefore we have negative 4 over pi squared. This is pi squared, n squared, because as you can see, the pi here will cancel. And so guys, that's how I can do that question. Thank you for listening to me. Bye.